Hello, everybody. Oh, it's working, awesome. And this is also working great. Charles, thanks for this great talk. I'm so glad that I'm not with a message here. Learning analytics will solve your stage and will be kind of Pavlov thing. So I'm really glad that this is not my message after Charles' slides. Thank you for inviting to this awesome place, to this creative space. In the Netherlands, we have a conference for teachers, about 700 people. Oh, wow, I cannot see anyone here. For 700 people. What I really like about this is this creativity here with the pantomime around and so on. So that's really stimulating our minds, and I hope it gives fly to that thoughts that we give here. So thanks for invitation. My name is Hendrik Drachsler. I'm working on learning analytics since a while. My background is computer science and also educational science and a PhD degree on both. Combined it in the PhD degree at the Open University. That was my thesis, actually. It was on recommender systems for navigation support for learners and lifelong learning networks. So there was no learning analytics at that time. That's 10 years ago. And when I started working on that, but actually it's still the same things we are thinking through. So it's data that we collect, we do matching, categorizing, personalization. And I'm still working on that topic, what is kind of really nice thing, because starting at that in 2006, I didn't know too much about it and did different things before that. And now learning analytics is the new umbrella term for these technologies. And the term is also approved because there are certain things changed to 2006, like MOOCs provide a lot of data, but also we at the university take much more care about the data we have there and we want to use. This is the Open University. This is our campus. There are no students. It's a very peaceful place. So Open University, totally relaxed. And everything is text-based, and that makes us open universities. Yeah, actually, we are really looking since years into technology for education and use this technology in data and provide personalized services, because our main concern is actually the dropout. Because what the dropout curve that Charles showed in his MOOCs, we also see in our normal courses, and we want to have the students engaged, support them at home, team them up. So we have a lot of things going on there. And it's all text-based, so we collect quite some data since years. Having said that, why I'm actually here, I was wondering. Because, I'm from the Netherlands, doing there some analytics, but giving an introduction to learning analytics. Why I give an introduction to learning analytics to the people and the teachers of it from Estonia? You're the ones that built Skype with 70 million people users online. It's the country that holds the most startups per person, so there's a lot of creative space. The country with the world's most digitized bureaucracy and also open data, transparent way. So I get a kind of, why I give an introduction to learning analytics? I guess those people come to the Netherlands and tell us how they do it. And finally, well, programming is part of your curriculum, so I can also imagine that the students could hack on their own data and do some interesting stuff and learn from that. So I think we are here. I'm not too much teaching. I think we're talking on the same level. I will share some thoughts in that presentation with you guys and hopefully get something back and learn something as well. Because I think Tallinn and Estonia can really take a leading role with this attitude for learning analytics and for educational technology in the future. So it's a city like Silicon Valley, London, Berlin, Tallinn. So follow this road, take this idea, take this paper flyer from the presenter of the morning and follow that road and make that achieve this. So I will shortly say a few words about why learning analytics, that goes to big data and what big data taught us so far and how is it related to learning analytics. Then I present the learning analytics framework that I invented with Wolfgang Krelle in 2012, what kind of makes learning analytics nicely in a nutshell for everybody to talk about. And I present some ideas, conclusions to you people that you could work on. So, well, it's more trivial, more ICT, more data. This data is valuable information, and there's a lot of demand to do something with this data, to mine it, to look for personal learning paths, and to personalize learning, to really give a personalized experience. Well, there's this big data economy. When you look, this is a screenshot from 2008 where the Google flu trend was there. Who knows about the Google flu trend? Hands up. Okay, not too many. So roughly that was one of the, well, it's one of the nice big data examples where Google actually, in a side product, found that with the search queries for the flu, they can nicely predict the Google flu on a map, and they are much faster and more accurate than the CDC was in 2008. Well, and that, the whole idea was actually 6 years ago then also to apply those technologies for learning analytics for education. So learning analytics is kind of data science for education. And that's it. And we have to bring together the data scientists and the educators to make it a meaningful tool. Another thing was also in 2008, Chris Anderson wrote something on Wired where they said, actually, theory building will be obsolete. We just have all these data bugs, and the data will tell us, and we will discover new things without having a hypothesis how learning works or something. We just dig into the data, run the machines on it, and then we found it. It was very controversial, discussed. But there was these really early ages of big data tools, and also going with the flu trend, so this will solve all our problems. So 2008. Well, that basically was kind of back again, so we are no longer believing too much into that, because also Google flu trend has been stopped. Therefore, it's also a nice example. It's a nice example for big data tools, but it's also a nice example how big data can fail, because actually they discovered over time that some things are not that accurate, that some search terms does not fit, and that it's not a tool that is really made for identifying the flu in and map that on the world. So there are more tools that are more accurate for that, especially for research. And I think for education, we should take that into account. So we really need to think carefully about the tools, and we have to design, and you have to design the tools with the data scientists that make prediction or reflection or whatever about teachers and students. So measurement, validity, reliability, and dependency of data are still important for having accurate analytic results. So it's not like we have a data bug, we run some machine learning on that, and that will find the answer for us. However, in November 2015, this theory was rather consistent, but then we had the DSAA conference in 2015, where some MIT guys ran again an algorithm on a data set for education, actually, and they claim that automated features, so that the algorithm also automatically identified the features that lead to dropout, and that this dropout is better predicted by the machine than by any human expert. So we are back in a discussion from 2008. Again, maybe big data is the overall wisdom, and it's a playing field, and that has effect on learning analytics, because we need to think about how to apply this big data technology that we are all exploring, that is very fast ways of technology that is used for education, how to use it in a purposeful way. So where we are with learning analytics. I always like to cite then the learning analytics sophistication model. So that basically gives 5 steps of sophistication of learning analytics. And when you look at the learning analytics sophistication model, you see in the first level it's aware, you make kind of dashboards, you can make some reports out of data and it comes back. On the second level you have then more drill down things, more stuff to use there. On the third level, I actually could also do that one. You have then student dashboards, teaching dashboards, and cross-system integration, what is a very important thing. At the Open University, we are currently working to getting a big data infrastructure for our university, but it's damn hard to get all these cross-system data integration, where some people even don't know anymore where the table is and where it is good for, into that new system. So that's really a difficult thing. And then 4 is really having predictive models, personalization of learning, and finally really having a sector that is changing. And I think that's also one of the objectives of this conference, to reach to level 5 within Tallinn, within Estonia, to be leading here. But now you can consider, where is my institution at that moment with learning analytics, on which level? Most of the levels are really 1 to 2 I saw some few examples that are on 3, so I think there's still a lot of work to do. So what is educational data? So we have data from learning profiles, learning from LMS, from MOOCs, from apps and so on, that all can come together, and surely also from assessments. Assessments is a big topic in the Netherlands. I think the Netherlands is the country with the most assessments a student have to pass for something, so assessment is a huge bulk of data for us. And with this data, for the first time, we can follow the learners in their learning behavior almost real time. I mean, they do the clicks online, we can directly see them in the dashboard with some delay depending on the computing models behind. So it's something that brings us to really on-demand learning measures. So there are certain indicators you are expecting, and you can see them live and almost real time. And that's something we didn't have before. We always had talks to students, or we did a survey or something and asked then the students how did they like the course. And then typically 15% of the students answer that survey, and that's the 15% that really like the course, or they find the course really shitty. So now we have 100% people, we can survey them and see their behavior really on demand. So some insights, just some examples. We talked about books. There was some example of books, and there's a transition from going from books to digital content. That's in a study we did for academic analytics, just the active proceedings, and we used the active proceedings and made social network graphs of the co-authors that are citing each other. Our hypothesis was, when we do this, then we get a big cluster of all the people, and because the European Conference of Technology and Learning is one big community that works together. Surprisingly, when we did that, we found that the actual community is not one community, it's more a cluster of very small communities, and these very small communities always citing each other and stick to their knowledge. That was something we didn't expect, and the Open University is here, the bigger cluster with Rob Koper, Marco Specht, and Eric de Waal, Martin Wolpers that work more often together in European projects. So there is some knowledge exchange, and there are some good things of the European projects. You can do the same for your courses. So if you have an online forum, you have a certain idea about a learning activity within the forum, so that the students should exchange information within the forum. Then you would expect something like this picture, like this is the tutor and the students also communicating with each other, and you can easily visualize that, and when you see that picture, you know, okay, the students follow my learning activity, it's going well, while if the students only talk to the tutor within the system, you know something is wrong, they didn't get the idea, so I need to have an intervention. And that's one example of such an on-demand learning measure after I introduce the learning activity, and I can watch 1 week later if it's going well or not. That's an example from the Open University. As I said, in the Open University, we are currently in a transition to being a big data, whatever, learning analytics university, because for us, really, dropout and time matters. You have to read this graph from the bottom to the top. So you start here. This is time, study time in days. This is one particular course, the green thing, and this is our activities within that course the students need to follow. So here are the activity numbers, and then you have to read it here on top. Basically, you put a ruler here, and you go up, and you can see what a student does. So that's pretty easy stuff. We didn't do 5 years ago, but now we take the timestamps. So the red one is one student following that course. So you see there are some activities, and he's starting up, and he does some stuff. He nicely fits actually to the curve what he do. Oh, here's something happening. Actually, student is faster than the learning activity expected, but then we have a peak where the student takes almost 10 days longer to do something, and instead of doing that task first, he completes some other tasks and gets back, and especially does not finish the course activities at the end. So that's quite interesting. So there is something about the learning activities 15, 17, 20 around, and also the student does not finish that. And that's something analytics gives back to us, to the teachers, to the institution, not really to the students. That's another page. And interesting it becomes when you put then the whole population or one population of that course over that. And then you see again, actually, when you look at activity 15, 17, 20, there's the same pattern. So something is wrong in our curriculum design here, because our students somehow stumble over these activities, and we need to focus on these activities and reorder them. And also most of them, it looks like they don't need to finish these activities, because that's not all dropout students, but somehow there's something specified, resources allocated, but it is not really meaningful for the student, and they don't follow up on that. So that's kind of insights and early experimentation with analytics that gives us interesting information and interesting information for the teachers to look at the course and the course design and changes to make it better and to make it more convenient for our students. So coming to Learning Analytics framework, Learning Analytics always has this notion of micro, meso, macro. Micro is then one class. You can scale it up as you want to. Meso is then institutional, or maybe a cluster of classes or a cluster of MOOC courses, and then macro is the regional, the state, or the university levels. And it's important to make differences between that, because you need different data and different analytics for each of these levels. So this is the Learning Analytics framework that we use to communicate to our teachers about what learning analytics is about and what they need to think about. It has 6 critical dimensions for us. So one thing, is the stakeholder side with institutions, teachers, learners, well, parents if you go for schools, maybe also companies. Then there's objectives of learning analytics. It's always about reflecting about activity or having then the magic prediction thing, right? Educational data, open data is a big movement, open courses and so on protected data. I mean, there's also certain information and data we don't want to give away, and we are by law forced to keep this data for 10 years, because if your house burns down, we still should have the files that you get a certificate at a certain level. And but we also need to protect this data. It's not something that should be on the web. Well, technology, educational data mining, recommender systems, statistical analysis, actually what's missing is visualization technologies. That's also very important these days. But there's also constraints. As well, maybe I get the idea that maybe in Estonia, this privacy and ethics discussion will be different, because you have so many free Wi-Fis, you have all the data, salaries are transparent, all the documents. I mean, you really have a different attitude here. In the Netherlands, there's also a big open data movement, but still ethics and privacy, and especially privacy information of personal information, is a big issue and could be a real showstopper for learning analytics. And this is why we really put effort on that, to train people on that and to build what we call trusted learning analytics tools. And then finally, competences, critical thinking about the analytics you get back, critical thinking on the side of the teachers, on the side of the students as well, and right interpretation skills. I had once an experience with my kids at school where I talked to a teacher, and they made one of these amazing CITO tests, what I do all the time, and I had some questions about the graph where my daughter was located in average to the average of the Dutch population. And she couldn't properly answer it to me, she just drew the conclusions from there. So, and that really made me scary. If we would go with learning analytics to a state that black machine, I don't know, black hole, gives some predictions and maybe even informs my kids what they need to study, and nobody can explain to me why that is. That's really scary idea, and I think that's something where human control is really important. And also by the Dutch law, decisions are always taken by humans and not by machines, what is a very important point. So diving into the learning analytics framework, so we have data subjects and data clients. The data subject most of the time are the students at the end, but in principle, if you would scale it up to meso, macro, or whatever, you guys could also become the data subjects of your organizations and need to talk about that. So data subjects, data clients that provide certain information. We do a lot of studies on the stakeholder side with the Dutch population. There was a study about where they see the highest impact of learning analytics on the Dutch education system. And what you see here, so they needed to provide some ideas that came up. We clustered them. So it was teacher empowerment, personalization, feedback performance, research and learning design, student empowerment, and some other things we put together. And then I needed to rate them on importance and on feasibility. And that's really expert, teacher-driven study. Most of the teachers see learning analytics to empower the teachers. That's very important. And they also think it's very feasible that learning analytics will empower them in their teaching. They don't trust their students too much, I have to say, because the student empowerment is important, but I don't think it's very feasible that the students can be empowered with learning analytics, what's kind of interesting. Luckily, with the Tallinn University, actually, we have a project called Shaila, where we now have the student population, the European student population, part of it, and will reconsider this information and also ask the students what they think about that. Objectives. So, as I said, reflection and prediction. Reflection basically looks like, you get some graphs. Well, that's just examples. You could even argue if you should present the average performance of a group to a student, if this is a good pedagogical behavior. But you get some visualizations back, you have some dimensions, you see your own performance, you see performance of others. So that's kind of the reflection part, where you reconsider things. And that's important for us. We implemented that in a distance education course where the students could choose if they share the information with the others within the group or not. And surprisingly, most of the students had no concerns about that and find it pretty good to share this information and also see the performance of the others, because at the end, they need to deliver a group work. And they used it to really trigger and monitor their group work. So it was kind of interesting for us. And yeah, prediction is the typical recommender Amazon thing. So you did that. Maybe you're also interested in this. And also predicting how good you will be in a certain course based on your prior knowledge. So data standards, that's one topic. Fighting Experience API versus IMS Caliper thing. Well, in the Netherlands, and I think in Europe, IMS Clipper is not really taking so much up. So we focus on the XAPI things, and we have some specification defined with actually all the activities that a student does within one of our courses. And when he does something in our course within our LMS, then this fires an event that goes then to our learning record store, so a central storage, where we store then all these activities. This is an open standard. You can just go to the website, have a look how we did it. Maybe it's applicable to you. It might become, with some adjustments, a Dutch standard for getting activity data from the LMS. So take it. It's also open and free to use. One other important thing is the data storage. As I said, we had a lot of data sets around, a lot of databases around, and actually we get a new thing here that's different data sets that communicate about the XAPI to an XAPI proxy, and this is then the heart of our big data analysis within the Open University's so-called learning record store that we set up that collects all this information, and it has the information from all student information systems at one place. So because we want to support the students in the best way, so if you're interested in a course and you maybe followed one of our MOOCs, we also want to marketing sites, chasing up, giving you a diploma, take your diploma within our courses again to further develop to really become a lifelong learning supporter of the studies of the Dutch organizations. Technology on the prediction side, I just put here this typical user-based filtering. That's not totally new technology. I mean, it's from 1994, where GroupLens did, I don't know who knows about news groups. There was these, well, my age wasn't these cool news groups where you then put these news groups and you get an abonnement and you get a lot of information, and it's still the same story. So you get a lot of information, you need to filter them, and then they applied the technology. So when you read the first article from the GroupLens guys about recommender systems, it's absolutely the same structure like when you go to the ACM Recommender Systems conference and read an article about a different information thing. Well, the algorithm definitely changed, but the argumentation is still the same. So, and you can do that on side of the user. So the recommendation here basically would be because that user here on the above liked A, that I get a recommendation for A because we have similar interest in that. And you can do the same what item-based filtering on Amazon does. So they use the items to see which are liked by others to recommend stuff to us. And then, sure, with analytics, you have a lot of fun. I mean, you can do wonderful pictures, and but they are not that meaningful for everybody. So that's a visualization of one of our courses where we put together whatever D3 JavaScript library could give us to visualize connections between different students, the tutors, the performance, and so on. And that gave this nice picture. What did not make it to our learning dashboard because it's too complicated, but it gives you some nice pictures. And the learning dashboard more looks like this, where you then have the course with certain performance levels and other things that you can follow the students on. Constraints, as I said, is about ethics, privacy is top at the moment, transparency, trust, and ownership, and policy making for this. Having policies to guarantee that, and a lot of communication, because trust you can only build up with communication. And if I'm a teacher and I collect all the data from my students, and I'm not transparent about that, what will they do? So there's this funny, I had a picture of once, there was a guy going to the library, and he was standing in the library and putting his ID card all the time over the library. And I said, yeah, what are you doing there? I need to increase my library engage score. So, and this is how he was fueling the system, basically. And that's something you don't want. I mean, then analytics becomes, again, a prison, becomes totally useless. So being transparent, communicating about information. So we really want to communicate with our students. We tell them why we need information take, what the added value is of them, and when we will throw this data away. Because they are also allowed to opt out at any moment and still get the same educational services. So we really want to make it a service for the students that they take the ownership of that, and that requires a lot of communication and trust. So InBloom, who knows about InBloom? Ever heard? I mean, that's one of the big failures in America where there was what I read about it was a wonderful system. Actually, it solved all the educational problems in the Netherlands, in the US, where all the schools have been connected to one central storage. There was an advanced privilege access system, but they made one mistake, investing $100 million, a lot of techies, but they did not communicate properly about it. And then InBloom in 2014 failed, and even the member states have been part of this initiative, needed to step down because there was a lot of pressure from parents' organizations and other organizations that they don't trust this data that is collected there, and they feared that this data will be sold to Google or whatever about the performance of the kids. And this is one of the examples why ethics, privacy is very important. Actually, I was invited to Washington to a conference to talk about ethics and privacy in Europe as a good model for the US, what was kind of surprising. So that's one of the big things, and since that happened, a lot of things are going on. So, for instance, the Open University of the UK, our big sister university, they have an ethical use of student data for learning analytics policy, where they really detailed to declare why they collect the data, for which purpose, when they, if you're allowed to opt out, and so on. So to make that very clear and to stick to that. Another thing also from the UK is the Code of Practice for Learning Analytics, where certain behavior rules, well, an attitude how to deal with learning analytics to get away from these surveillance systems idea. Within the LACE project, we developed now, and we'll present that next week at the LUC conference, the Delicate checklist. Delicate is an 8-point acronym for dealing with privacy and ethics issues. And we believe if you follow, so we actually did studies over 1 year on ethics and privacy for learning analytics. We were sitting together with lawyers and policymakers within the Netherlands, but also Washington, Paris, and other places, to come up with a way that learning analytics can be implemented and don't have another InBloom in Europe. That's all reported in that article, basically, also the dangers and fears. And we came up with a solution where we think learning analytics is possible, but it also needs certain features that enable this trust and communication and supporting the students in that. Competences. Competences are very important. As you see in that figure I found somewhere on the web, was there's 90% of the data in the world has been created in the last 2 years. I don't know from when the figure is, but a lot of data has been generated with the whole movement, and only a fraction of that is analyzed. But already now, almost almost all students, teachers, or information people say they are overwhelmed with data, and you really they need to have new competence to deal with that. So competence is really an important thing, especially for teacher education. So illiteracy, interpretation skills, agency, to be able to look at data, critically ask about these data, being able to deal with the data on the right way, and privacy understanding. So also the data that you collect, think about what you collect from your students, how you can be assured that you keep the security and analyze the data. And why is that so important? There was one very funny example in the Netherlands. This is a bachelor study of two bachelor students from Amsterdam. And the whole bachelor thing was just they built a little script where they used these Foursquare and Twitter thing where people check out their houses and check in, I don't know, somewhere else. And they used this information and put it on a website they called pleaserobme.com. So, and then the people were really pissed. I mean, it was in the news. They were, put me off of this website. I don't want to be there. That's not okay. I mean, but the guys didn't really do something. They took just some data snippets out there, put it on the website by an automatic API, and then it was on the website, and the people have been there. And it was a lot of fuss about that. But this shows that people are not really, I mean, they find it cool to check in and check out stuff, but if they end up on a page with pleaserobme.com, they don't find it funny anymore. And this is where competences for analytics, for students and teachers, is really, really important, also for the educational way. What we do in the Netherlands, we had this linked up project where we developed the LAC data set. So that's one data set. And what I like about this screenshot is actually that this is one data set represented in different ways. So different algorithms, different technologies to present the information that is within that data set. And if we use that to show that to our teachers, to tell them, listen, this one data set, different representation, some of this information is actually conflicting to each other. So it's not really that accurate. You can have different truths out of this data set. Then they start to think about, okay, that's actually, so you cannot really trust any visualization, as you should not trust any statistics. You really need to be aware of the whole chain of where's the data coming from, how is the algorithm running, and how it's coming back. And I know I'm asking for a lot here because you have to teach, you have to work with your students, but be aware, not every analytics and visualization you see is trustworthy. So, getting to the conclusion, we need you. We need the teachers of Estonia and learning analytics needed to really build that up, to build up trust and to have guidance. You cannot just put data scientists somewhere, give them your data sets, and they come back with something. I mean, they're not that passionate about teaching. They don't know about the contextual information. They might not have the pedagogical objectives to also train students that are not that good, well-performing, and you want to support them. So it's not something, give the data to the people. You guys need to be involved in the process. So the whole thing about the Learning Analytics framework is actually where you really needed is that we have pedagogical behavior that goes into the Learning Analytics framework, give us some information, and then we have pedagogical consequences that need to be taken into account again. And well, so data science without context knowledge, I would say, will not be a success. You need to have this context knowledge, like I showed with the Google Flutrend and other things. You need to have context information to make it really meaningful and accurate. And data science and context knowledge together will be a success. And in the Netherlands, within the SURF Foundation, what is the foundation of all universities, but also in the KennisNet Foundation, we seriously discussing about that at school organizations, so we have broader school organizations, each organization might have a data science group or something that really actively works with the students on their contextual data to get meaningful information out of that. So get involved in learning analytics at your organization. It's not only data model and transform, it's creative data sourcing, necessary IT support, question-driven, not data-driven or IT-driven. Your questions need to be answered. The questions of the students need to be answered. There's a lot of things to discover in data, and you will be surprised, but you should answer real questions that will help you. And participatory design is actually what I have a pleasure for, that you are involved, that people are involved, and that we design that future together. So there's not one size fits all. I'm really think if your manager comes to you and say, well, we have to tick the learning analytics box and we bought this product and then it's solved, I have doubts that that will solve your answers and it will not improve your teaching. So it's really a process where we need to become aware of, where we need to work on. Finally, if you need to look for friends out there in Europe, there's the Learning Analytics Community Exchange Project, the LACE project. Go to the LACE project. It's a community we're building up. We have quite some good channels there, policymakers involved, and some other people. So if you're looking for friends outside Estonia or wherever, go to the LACE page, become a member, and come to some of our events. Thank you so much. Yes, please.
Thank you very much for this excellent presentation. I was just wondering, as Tartu University will be recruiting a learning analytics professor later this year, would you be interested?
This recorded, I cannot answer that in public, sorry. That's one of these disclosure information. Thank you. So as I said, I'm really glad that I didn't come with the Pavlov thing like big data will teach your students in the future after Charles' talk. No other reaction on that? I don't know who knows about learning analytics? I mean, after that talk, before that. Hands up, who knows about learning analytics and how to apply it? Okay, there's still a way to go. Hi. Oh, thank you so much.